Tell you right now, I am not randomly picking this out of the air. Okay, it is picked deliberately. This is hard. This truly, of all the things that we do in this unit, I think sketching the antiderivative and sketching like the derivative of a graph can be the hardest part. I want to start with part F, and I want to be really careful, really deliberate about this. Those of you that like totally understand what you're doing, I want you to hold back a little bit. If you don't need the help on part F, you're working on the multiple choice, you're looking over the gold sheet, you're looking at the physics stuff, whatever else you need. But I want like all the brains with me on sketching the antiderivative. So where are those folks? So make sure I know. Okay, so this is the graph. What's this the graph of?
The double prime. No, derivative.
This is f prime over here. It's really important that you keep this straight in your head, that we're looking at the graph of f prime. And I'm asking you to sketch the graph of f. So normally when I think, I'm like, oh, here's f prime, here's f double prime. David, this is what you and I were just talking about, right? So here's f prime. I want to sketch little f, the antiderivative of the derivative. I will always tell you at least 1 point on the graph. I'm going to give you the starting point. And I gave that to you in this one, right? Mm-hmm. Where's the starting point?
-6, -2.
F of -6 equals -2. That means start at the point -6, -2. The fancy word for this, right? That's your initial condition. So I'm going to go over to the point, -3, -4, -5, -6, -2. I'm not going to get all OCD on my graph. I just know I'm going to start here. And then the conversation is, come back to the graph of f prime. And what do you, like there are different intervals that we want to pay attention to. The way I like to do it, I say, well, let's see. Starting at -6, I know that my graph is negative. And my graph is decreasing. So for as long as the graph of the derivative is both of those things, I'm going to look on that interval. And so I know that f prime, you guys just told me, is negative and decreasing. What does that mean about little f? If f prime is negative, and if you need to think about it in the chart, that's fine. F prime is negative and decreasing. So the two things that are true about little f? Careful, if f prime is negative, then f is decreasing. But if f prime is decreasing, then little f is concave down. Right? It's always it's a concavity thing, an increasing, decreasing thing, then a positive, negative thing. And because you knew f prime was negative, that's why f was decreasing. Because f prime was decreasing, f must be concave down. So I'm going to come down here to the graph of little f, and I need you to sketch for me decreasing, concave down. So just draw it in the air. What does that look like? Decreasing, concave down. If you can draw it in the air, then Edgar just made a circle.
No, I did.
Oh, Abraham, sorry. I need decreasing, concave down, so I'm looking for something like that, right? So I'm going to say from -6 all the way to -3, draw decreasing, concave down. And make sure you're stopping at -3. Is everybody good on that interval? Okay, have a conversation with somebody near you. What's the next interval and what do you know?
-3, 0. And you know that f prime is increasing. Means that f is positive.
So it is negative.
I'm going to pretend I don't hear all these it's being said.
Oh, God. Wait, it's negative and increasing.
All right. So I heard from most of the groups, it sounds like we know f prime is negative and increasing. Negative and increasing. Both things are happening. So the graph of little f has to be, if f prime is negative, then little f is decreasing and concave up. So draw decreasing, concave up. Decreasing, concave up has to look something like that. Right? And I'm just going to say, oh, from -3 to 0, decreasing, concave up. I'm just curious. How many guys honestly had decreasing concave up? We're in a good place. All right, Jonathan, next interval. What's the next interval that you're interested in? From 0 to 3. What do you know from 0 to 3?
It's positive and
Oh my God, what? I haven't written your letter of recommendation yet.
F prime is positive.
F prime is positive and increasing. So Jonathan, the thing that you know about little f?
It's concave up and positive.
Concave up because f prime is increasing. F prime is positive, so little f is increasing. I need increasing concave up. Increasing concave up on this next interval. Last interval. F prime is, what is this? Decreasing and positive. So Mariah, what's happening on that last interval? F prime is decreasing and positive.
It is concave down.
Concave down and
Decreasing. Negative.
wait.
No?
F prime is decreasing, so F is concave down.
Yes.
But F prime is positive, so
Oh,
F
it's
is
increasing.
increasing. I need concave down, increasing, which I think looks like that. Okay, now before you leave this problem, right, you want to like wrap it up. The last thing I need relative extrema and points of inflection. Daisy, where are the relative extrema?
At negative 3.
At negative, you're saying at negative 3?
At 0.
At x equals 0, what kind of extrema?
Relative
A relative min at x equals 0. So now with the graph of f in front of you, I think it's pretty easy to say that you know you've got a relative min. You can tell me why from f prime. F has to have a relative min. I see Ranbir, I see Edgar, I see Noemi. All right, Ranbir, what do you know?
It's the point of inflection
F prime has a point of inflection?
where it switches concavity.
Okay, that is true. F prime is changing concavity. We're changing from concave up to concave down. That's true. But that's not why F has a min.
But did you take notes on that?
I did, yeah. F has a relative min, F prime. Marvin, you want to help him out?
It goes through 0 and changes from negative to positive.
F prime is changing from negative to positive. That's what, because this is F prime, that's why F has a relative minimum.
So even if that graph is like switched over a couple units, it's because it's crossed upward.
It doesn't matter about the point of inflection. It matters that F prime is changing from negative to positive. That's why little f has a relative min. Daisy, what's up?
What about there's a vertical asymptote there?
Not a vertical asymptote.
Vertical tangent.
There's a vertical tangent line. That's going to impact your graph of f prime's derivative, not the antiderivative.
F double prime.
F double prime. That's why I want to get to that. All right, so relative min. Any relative max?
No.
No, and I can look at f prime. I never see f prime change from positive to negative. Don't use the psychic powers and say, oh, I think after 6. I don't know about after 6. Okay? Points of inflection? Any points of inflection? Anybody see any points of inflection? Jennifer sees some, Ramir sees some, Marvin sees some, Abraham sees some. Jennifer, what do you know?
At negative 3, negative 4.
Okay. The thing for sure, it's the x coordinate that you know. The y coordinate, this is just a sketch. You don't know enough to tell me y coordinates. But a point of inflection at x equals negative 3, that's one of them. Where else? Where else? Where else? Noemi, where else?
At x equals positive 3.
Positive, point of inflection at x equals 3. So the last question, why? Why is there a point of inflection, Abraham? Why does f have a point of inflection at x equals negative 3?
Because the function changes concavity.
The function f changes concavity, true, but there's something about f prime. There's something about f prime. Noemi, what's happening with f prime?
At that point, f prime changes from decreasing to increase.
Right, f prime changed from decreasing to increasing, so f just changed from concave down to concave up. Okay, I care greatly if this is a tough skill. All right, so if you're good with that, feel free to use the gold sheet, do whatever else you need to get ready for this quiz that starts in 7 minutes. If anybody's struggling with the sketch of f double prime, we can have that conversation if anybody wants to talk about f double prime. Ranbir, you want to talk about f double prime? Fabricio, you're done? Yeah. See you later. Okay, so just me and Rambir. You can go to the restroom, yeah. Daisy, you want to talk about F double prime? Jennifer wants to talk about F double prime. Mariah wants to talk about F double prime? Can you guys maybe come up front? And then you guys to move so I can make some space here. Alright, folks that are talking about F double prime, come on up front. When my alarm goes off in 6.5 minutes, we have to stop all the fun. Alright, F prime, F double prime. Hello. Noemi has some new friends to play with. And Rambir, you were with me on this, right? Alright, so we've got F prime, I want F double prime. Different thoughts, right? I think this is the hard part. You're like, you've got F prime, F double prime, you get this antiderivative. Which way are you going? Like, make a little chart on the side if you need to. If this is F prime and I want F double prime, what are the things that you know for sure here? And what does it tell you down here? Rambir, get me started.
We know F prime is decreasing the content of F.
Okay, on this first interval, you can say F prime is decreasing, and what kind of concavity did you say?
Oh, concave up.
Okay, concave up. So F double prime, what do you know?
Oh, that it's negative and that it's increasing.
F double prime is going to be negative and increasing. Now, the hard part, I think, with the second derivative, I don't have an initial condition. I don't have a starting point. But if you show me that from -6 to -3, your second derivative is negative and increasing, I'm going to say, all right, you know what's going on. But a great way to start your graph, there are some easy things. There are some easy points to pick up. Where are the easy points?
The horizontal tangent line.
Horizontal tangent lines, right? There's a horizontal tangent line over here. Jennifer, why is that helpful? Why does that help you with F double prime? If this graph has a horizontal tangent line, then those are the roots. I have to have a root over here at -3, and I have to have a root over here at +3. So I've got a guide. Yeah.
Is that only true for F prime, not F double prime?
Well, this is F prime, and this is F double prime.
Okay.
If I called this F, you could tell me about F prime. If I called this position, you could tell me about velocity. If this is velocity, you can tell me about acceleration. All the stuff. Okay, we got the roots. Roots are great guides because now you're going to sketch something that's negative and increasing and passes through the root. There's one more thing I'd hope that you'd tell me. There's no cusp points, but what is there?
Vertical tangent line.
Vertical tangent lines. I've got vertical tangent lines over here at -6, at 0, and at +6. So if this guy has vertical tangent lines, the derivative will not exist, that's true, but there's a specific way that it doesn't exist. Christian, do you remember? You had vertical asymptotes. Rambir, is that what you were going to say? So I'm going to draw my vertical asymptotes. -6, 0, 6. Those are my vertical asymptotes. Already a great graph. The rest, we're almost done. And honestly, if I was doing this, I'd start with my roots and my vertical asymptotes first, because those are good guides. So now I was told my graph of F double prime is negative and increasing from -6 to -3. If I have a vertical asymptote and a root, there is only one way to draw a graph that is negative and increasing, that has a vertical asymptote and that has a root. What would that look like? What do you think, Daisy? What would that look like?
It'll have to go through the root, but
Okay, number one, it has to go through the root. I have to be negative below the x-axis and increasing, and I got a vertical asymptote. So I think the graph's going to have to look something like that, because I have to obey the law of the vertical asymptote. The vertical asymptote's pulling me down towards infinity. Okay? All right, so have a quick conversation with somebody near you. What's happening on this next interval? let's see. F prime is increasing concave up. So F double prime must be positive and positive because F prime is increasing. Increasing because F prime is concave up. So I need positive and increasing, leaving the root, heading towards a vertical asymptote. The graph has to look like that. Okay? Next interval, we're totally running out of time. I'm going to go from 0 to 3. And on this interval, I'm increasing. What is this? Concave down. Increasing, concave down. My derivative graph, Edgar, what does it have to be? Positive and decreasing. Positive and decreasing, vertical asymptote and a root, has to look something like that. And then on my last guy over here, we're going to say, what is that, decreasing, concave down. So I come down over here, F prime was decreasing, F double prime is negative, F prime is concave down, F double prime is decreasing. And I've got a root, and I've got a vertical asymptote. So negative, decreasing, bada boom, bada bing. That's that. All right, so let's clean it up, shall we? Oh my God, perfect timing. Did you hear that? Like the last word came out of my mouth, the timer went off. Perfect. I just wanted to get that perfect moment on film, Mariah. We can turn that off. Yep.